Hello everyone. Today we are going to see about the inverse Z transform using partial fraction method. So find the Z inverse Z transform of capital X of Z is equal to Z into Z square minus 4Z plus 5 into Z minus 1 into Z minus 2 into Z minus 3. For the ROs is mod Z lies between 2 and 3 and mod Z greater than 3 and mod Z less than 1. Solution. First, x of z is equal to z into z square minus 4z plus 5 divided by z minus 1 into z minus 2 into z minus 3. Dividing this x of z by z, we will be getting x of z by z is equal to z square minus 4z plus 5 divided by z minus 1 into z minus 2 into z minus 3. Now, since we are using this partial fraction method, this above equation can be written as x of z by z is equal to, since you will be having z minus 1. So the numerator, I will be getting only the constant part. So a divided by z minus 1 plus b divided by z minus 2 plus c divided by z minus 3. So we need to find the constants a, b and c. To find a, what we have to do is the denominator of a is z minus 1. So this z minus 1 is multiplied by x of z by z. So z minus 1 into x of z by z value is z square minus 4z plus 5 divided by z minus 1 into z minus 2 into z minus 3. Here, to find a value, you have to substitute z is equal to 1. Okay, so this z minus 1 and z minus 1 term will get cancelled, and for the remaining terms, you have to substitute z is equal to 1. So I'll be getting 1 square minus 4 into 1 plus 5 divided by 1 minus 2 into 1 minus 3. So I'm getting 6 minus 4 divided by minus 1 into minus 2, which is 2 by 2, which is 1. So a value is 1. To find b value, the denominator of b is z minus 2. So to find b, I have to multiply this z minus 2 by z x of z by z and substitute z is equal to 2. So z minus 2 is multiplied by x of z by z, where you have to substitute z is equal to 2. So z minus 2 into z square minus 4z plus 5 divided by z minus 1 into z minus 2 into z minus 3. So this z minus 2 term will get cancelled, and for the remaining terms, you have to substitute z is equal to 2. So 2 square minus 4 into 2 plus 5 divided by 2 minus 1 into 2 minus 3. So I'm getting minus 1 as the value. So b is equal to minus 1. To find c, the denominator of c is z minus 3. So you have to multiply this z minus 3 term with x of z by z. So z minus 3 into z square minus 4z plus 5 divided by z minus 1 is z minus 2 into z minus 3. So z minus 3 term will get cancelled, and for the remaining terms, substitute z is equal to 3. So 3 square minus 4 into 3 plus 5 divided by 3 minus 1 into 3 minus 2. So we have got c to be 1. So a is equal to 1, b is equal to minus 1 and c is equal to 1. So hence x of z is equal to, or x of z by z equal to 1 by z minus 1 minus 1 by z minus 2 plus 1 by z minus 3, from which we have got x of z is equal to z by z minus 1 minus z by z minus 2 plus z by z minus 3. We know the formula, that is Z transform of a power n into u of n. This is an infinite series formula. For this term, a power n into u of n, if you take Z transform, the form, that is the output you will be getting is z by z minus a for the causal sequence. That is the positive sequence. So when we will get the causal sequences, when z is greater than 0. When z is greater than 0, then those sequences are causal sequence, and when z is less than 0, they will be calling as anti-causal sequence. That is a negative sequence. So z inverse of minus a power n into u of minus n minus 1 is equal to z by z minus a. For causal sequence, you have to substitute a power n into u of n. Okay. If for the anti-causal sequence, if you have this term, that is z by z minus a, You have to substitute minus a power n into u of minus n minus 1. Now, we have three cases, okay, three ROCs. So, case 1, 2 less than z less than 3. So, this thing, we can write it like this. That is, first one is mod z is less than 3. When z less than, so if you have less than symbol, that is when z less than symbol, then this is called an anti-causal sequence or a negative sequence. Here, the second term is 2 is less than z, or we'll say mod z is greater than 2. When z is greater than 2, we'll be telling it as causal sequence, that is positive sequence. So, this is our x of z. That is x of z is equal to z by z minus 1 minus z by z minus 2 plus z by z minus 3. So, we have three poles. What are they? 1, 2 and 3. So, in this ROC, we have two ROCs. That is, one is mod z greater than 2 and mod z less than 3. So, since our ROC, that is mod z is greater than 2, this poles 1 and 2, that is when z is equal to 1 and z is equal to 2, are causal part. They will provide causal part, and this z is equal to 3, it is out of ROC. Okay, so that's why it provides an anti-causal part. Now we are taking the inverse Z transform. Inverse Z transform of x of z is x of n. That is inverse Z transform of what is our x of z? Z by z minus 1 minus z by z minus 2 plus z by z minus 3, which is equal to, see, for this first term z by z minus 1, it looks like z by z minus a, and this is the causal part. For this, the x of n terms should be z by z minus a. X of n terms should be a power n into u of n for causal sequence. So here a term is 1. A is equal to 1. So a power n into u of n, or 1 power n into u of n. Here you will be having minus symbol. So put minus symbol. So this is also z minus 2 and this is also a causal part. So write a power n into u of n where a is equal to 2. Whereas the third term z by z minus 3 is an anti-causal term. So for this anti-causal term, we are getting x of n to be minus a power n into u of minus 1 minus n minus 1. So here my a part is 3. Okay. So minus 3 into the n, that is minus a power n, that is minus 3 power n, u of minus n minus 1. So x of n is equal to 1 power n into u of n minus 2 power n into u of n minus 3 power n into u of minus n minus 1. This is the for this ROC. The case 2, mod z greater than 3. So already I've told you, whenever z is greater than some value, then that signal is termed as causal sequence or positive sequence. Okay, so here the ROC is mod z greater than 3. So the signal x of n is causal or positive sequence. And here we have three poles. What are they? Z equal to 1, Z equal to 2. So here 1, 2 and 3 are our poles. And these three poles are greater, that is, are less than 3. Okay. So all these three terms are causal terms. So x of z is equal to z by z minus 1 minus z by z minus 2 plus z by z minus 3. So taking inverse z transform, x of n equal to 1 power n into u of n, that is a power n into u of n. Here a term is 1 minus a power n into u of n. Here a is equal to 2. So 2 power n into u of n plus 3 power n into u of n. This is for the second ROC. The third case is mod z less than 1. So whenever we have the mod z less than 1, then that particular signal is an anti-causal sequence. Okay. So here all the three poles, that is z equal to 1, z equal to 2 and z equal to 3 are anti-causal terms. So x of z is equal to z by z minus 1 minus z minus 2 plus z minus 3. If you take anti-causal, For the first term, I'll be getting minus a power n into u of minus n minus 1. Okay, so here x of n is equal to minus 1 power n u of minus 1 minus n minus 1 minus of this term you will be getting minus 2 power n into u of minus n minus 1 plus minus 3 power n into u of minus n minus 1. Okay, so minus 1 power n is always minus 1 into u of minus n minus 1 plus 2 power minus into minus plus. Okay, plus 2 power n into u of minus n minus 1 minus 3 power n into u of minus n minus 1. So if you take u of minus n and minus 1 outside, I'll be getting minus 1 plus 2 power n minus 3 power n. Okay, so thanks for watching this video. Thank you so much.